This is a video on how to do problem 3 on test number 1 for physics 2212 because it's the one that I missed some points on and I'd like to get credit for this test wrapper. So pretty much here we have a small glass ball, as we can see. It's rubbed all over with a small silk cloth and acquires a charge of +5 nanocoulombs. The silk cloth and the glass ball are 30 centimeters apart. If any electric fields you are asked to draw 0, state this explicitly. Pretty easy question for the most part. So first one is just a very simple, what direction does the electric field go? At the location marked X, we can see right here, due to the silk cloth and the glass ball, we understand from most of the unit that the glass ball is a +5 charge, I guess, and silk cloth is definitely a negative charge, because when you transfer electrons, or when you transfer charge, you don't transfer electrons per se, but you do transfer the orientation and the I guess observational location of electrons. So since we know that the glass ball acquires a positive charge, the net system must be 0 as before, so the silk cloth has to have a negative charge of pretty much equal value. And so to find the electric field, we know the silk cloth is closer, so it definitely has by magnitude a larger electric field, and we know that negative charges are sinks, so it goes toward the silk cloth. And for the field due to the ball, we know that since it's a positive charge, the electric field moves away from the positive charge, but because of the distance, since the electric field is inverse of the distance squared of a point charge, it's a smaller value than the electric field due to the cloth. Now, when you place a metal block in between them, because it's a metal block, we know it's a conductor, and so electrons do flow freely, and it'll polarize the metal block here accordingly, and so the electric charge shouldn't really change in the entire system. And we know just from the textbook that because electrons are so free to move and to balance out the charge, the E net is 0 for a conductor such as this. What's important to note is that because it's a positively charged metal block, it's all positive charges around the block, and to differentiate between the polarization, we just have to draw a greater concentration of these positive charges on the appropriate end, and then you do the same with the electric fields as we did before. Now, the interesting part here is that the location marked X, draw and label 4 arrows using the same scale. So now we have the same thing, except here we have a neutral plastic block, and so electrons are not as free to move. They're only really free to polarize in a very small area, and so the electric field due to the cloth, E, I pretty much just didn't do most of this question, but pretty much you do have to draw within the actual box and draw the small dipoles that must orientate themselves away from the positive charge and toward the negative charge, as we can see here. And P will denote the I guess the polarization of the dipole, as you see here, and you can see that the positive charge is moving away from the positive, and the negative charge is moving toward the positive, and vice versa for the negative charge here. Otherwise, that's pretty much it. If you have any questions, you should ask the professor and attend plus sessions. That's all I can really help you with.